Now that you've learned about elasticity and earthquakes, you may wonder what professional works on earthquakes. Well, those professionals are geophysicists or geoscientists. They are, for instance, working in the field to monitor earthquake activity, seismic activity. For instance, Asaka Milkius here is monitoring Hawaiian volcano. The median salary for that job title is of $83,680 per year. To get such a position, you will need to get a bachelor's degree in geoscience or physical science. And there is a demand for this kind of job since it is predicted that there will be a 5% growth over the next 8 years. To become a geophysicist or a geoscientist, you will need to master some basic skills such as oral and written communication to write report for stakeholders, your N+1. You need to have good critical reading and thinking. You may have to be good with computers and good at making decisions. Specialized skills may include physics and math to make calculation and interpret data, especially if you apply those skills to rock properties. And the calculations may be done in Excel, or you may have to be able to code or to manipulate data in ArcGIS. The competencies that the job market is looking for a geophysicist include interpersonal skills, time management, organizational skills, ability to work independently but also in teams, and eventually in remote areas. Professional geoscientist license may be required for advancement beyond entry-level position. So, if you were to work as a geophysicist, what would you be doing? Well, the first thing to do would be to investigate, to gather observations about rocks, oceans, gravity, other properties to understand the Earth's origin and behavior. You may have to collect rock samples, or you may have to collect geophysical data using some measurement device, GPS devices, seismograph to have a holistic view of the region and its seismic activity. Then you will have to take those data and analyze them. So you may have to do some further analysis in the lab on a sediment and rock to understand their property, their elasticity, for instance. You may have to analyze the geophysical data to visualize them and interpret the Earth structure. You may have to use computer simulations to predict natural hazards. You may also have to develop a plan to conduct field remote sensing computer simulation studies. And finally, this is where the communication skills are very important. You may have to prepare written scientific reports, present your findings to colleagues and external stakeholders, and you may also have to review reports and research done by other scientists.